In this video, we're going to study more examples of adding and subtracting rational expressions. This time, we're going to use so-called LCD, the least common denominator. And I'm going to explain what it is in a moment, but let's take a look at an example first. So in this example, we have two rational expressions added together. And they have different denominators. See, x cubed and x squared, they are different. So if they are different, we need to find the common denominator. So find the common denominator, we can use the method I have explained in the last video. Simply multiply the denominators, and that's going to make a common denominator. But we can do better than that here. See what I'm doing? We're going to simply multiply the second rational expression by x over x. If you do that, see the denominator is x squared times x. That makes x cubed. Now we have the same denominator, right? And x cubed is 3. The power is less than 5 here. Okay, 3 is less than 5. So in that sense, x cubed, this is called the least common denominator. So let's continue to do the work here. Let's continue. We have 2 over x cubed. Now if you multiply x over x and 5 over x squared, it's 5x over x cubed. So now we have the same thing in the denominator, so we can write it once and add up the numerators, 2 plus 5x. So here's the second example. So I'm going to explain what LCD is really. This is basically the product of the highest powers of factors of denominators. So here we have two denominators. Before we take LCD, we have to completely factor everything out. So 4 is 2 squared. And x, y, they are already factored. So let's write them down. And 6 is 2 times 3. And we have x, y squared, z to the 4th. So LCD is basically the highest power of everything. So we have 2 squared here and 2 here. The higher power is 2 squared. And then we have 3 here. That's the highest power. Take 3. And then look at x is x squared, and x squared is higher power. Then take y's, y cubed and y squared. We have y cubed, higher power, and z to the 4th. Z to the 4th is the higher power. So this is the least common denominator. So the next thing to do is to multiply the rational expressions by appropriate factors to make the denominator look like the LCD. So we need 2 squared. 4 is 2 squared, so it's already there. What we are missing is 3. We need a factor of 3 here. And x squared and y cubed, they are already here in the denominator, so we don't need them here. But if you look at z to the 4th, we have only one factor of z in the denominator, so we need 3 more factors of z to make it the 4 factors of z. Now put the same thing on the numerator. Okay, now let's work out the second rational expression. And think about what is missing in the denominator. So 6 is 2 times 3. So we have one factor of 2, one factor of 3. So they make 6. So we are missing one more factor of 2. Multiply 2. Now we have one factor of x. So we need 2 factors of x. So we multiply this by x. And we have 2 factors of y, and this is y cubed. We need 3 factors, so one factor is missing. So multiply y. Y squared times y make y cubed. And z to the 4th is already there, so that's it, 2xy. So multiply the same thing on the numerator. So let's scroll down a little bit. I'm going to need more space. And if you multiply these out, we're going to have the same LCD. 3 times 4 is 12, and we have x squared, y cubed, z to the fourth. In the numerator, we have a 21 z cubed. And the second term is 12 x squared, y cubed, z to the fourth in the denominator. And in the numerator, we have 10xy. So put two terms together. Here is the denominator, and add up the numerator. We have 21 z cubed plus 10x times y. So that's the answer. Okay, I want to show you one more example. So let's scroll down. Okay, here it is. If you look at the denominators, there are 3 of them: x squared minus 4, x plus 2, and x minus 2. To find the least common denominator, we have to factor everything out. So what is x squared minus 4? This is difference of 2 squares. So it is factored as x plus 2 times x minus 2. So the least common denominator is the product of everything. So here we have x plus 2 and the same factor of x plus 2 in the second denominator. So let's use it just once. And x minus 2 and x minus 2, we take the product of them. So now we have everything here. X plus 2 times x minus 2 is the same as the denominator of the first term. But it also contains the second term, the denominator of the second term, and also the denominator of the third term. So now let's use this LCD to add up these expressions. The first denominator is the same as the LCD, so there's nothing to do with it. For the second one, we have x plus 2, so that's missing x minus 2. So multiply this by x minus 2 over x minus 2. Okay, the third term, 1 over x minus 2. In the denominator, we have a missing factor. X plus 2 is missing, so we multiply it. X plus 2 over x plus 2. Okay, we need more space. Write down the first term as it is. In the second term, we multiply them out. Multiply numerators, we have x minus 2. Multiply denominators, x plus 2 times x minus 2. And notice that this is the same as x squared minus 4 if you expand it out. And here is the third term, x plus 2 over x minus 2 times x plus 2. So we have let me write down the denominator in factored form. And let's add and subtract the numerators. We have 2 plus x minus 2 minus x plus 2. Remember here, again, when you add or subtract, if you want to subtract in particular, if you want to subtract more than one term, here are 2 terms, you have to surround them with parentheses. So now we can simplify everything. We have 2 plus x minus 2. Distribute the negative sign, negative x or minus x, and then minus 2. In the denominator, we still have x plus 2 times x minus 2. Okay, now we have 2 terms of x plus x minus x cancel out, and 2 minus 2, they cancel out. So we're left with minus 2 on top, and x plus 2 times x minus 2 on the bottom.